Hi everybody, welcome to your week 7 worksheet video. What you're going to need for this worksheet is your circle theorems reference sheet. What you see here, you can download it from Canvas in the assignments or on the home page. Okay, you're definitely going to need it. So have it next to you when you're doing this worksheet. So the first set of problems says we're going to find the measure of the arc or angle indicated using the tangent chord theorem. Okay, so locating your tangent chord theorem on your circle theorems reference sheet, and we'll get started. So for number 1, we're looking for the arc RS. Oh, just kidding, we're looking for this arc right here, the major arc RS. Okay, and what I do know is the fact that the minor arc RS and this angle right here are connected by the fact that RS is going to be 59 times 2. Okay, so 59 times 2 is going to give me 118. Okay, but I'm looking for the other side, the major arc portion RS, and I'm going to need to find that by subtracting from 360. So I just take my 360 minus 118, and that's going to give me 242. Okay, and you're done there. Similar thing, but you're going to go a little backwards because you're going to be searching for this angle versus the arc measure. Okay, this next set of problems says we're going to use the 2 secants theorem. So locate your 2 secants theorem, and I'm going to solve for this angle S here. And to solve for that, it says that angle S is going to equal to 1/2 times my outer arc, 156, minus my inner arc, 146. So angle S is equal to 1/2 times 110, and 110 divided by 2 is just 55 degrees. Okay, all set there. Same method for number 4. All right. These one says use the tangent secant theorem. However, when you locate your tangent secant theorem for finding angles, it's actually the same as your 2 secants theorem. Okay. So number 5, let's talk about this because it's a little different. We're going to solve for my outer arc. So I know that 40 is equal to 1/2 times x that I don't know minus 105. Okay. Now what we're going to do here is we could distribute my 1/2, but that would give me fractions, that would give me decimals. What I can do instead is just multiply everything by 2. That's going to cancel my half and make sure that you multiply the 40 by 2 as well. So I've got 80 equals x minus 105. Now it didn't affect my x minus 105 because it was canceling this 1/2 on that side, all right? Now I just add my 105 to both sides and find out that x equals 185. And you're done, okay? Use that same tangent secant theorem on number 6, okay? These next couple ones says using the 2 tangent theorem, okay? So I'm searching for this angle, this arc here, which on your reference sheet is labeled as n degrees, okay? So we'll call it n, or in my equation I can just say CE. Arc CE is equal to 180 minus 56. Super easy. So CE is equal to 124 degrees. And you're all set there, okay? Similar thing, but you're going to solve for your major arc on that side, okay? Now we're using our two-chord theorem. So solving for this angle right here. In my two-chord theorem on my reference sheet, that means that 82 represents N and 56 represents M, okay? So I'm solving for X, and that's going to equal 1/2 times 56 plus 82, okay? So adding those two together, 56 plus 82 gives me 138. So 1/2 times 138, and that's really 138 divided by 2, which is 69 degrees. Okay, all set there. So just making sure that you read your two-chord theorem very carefully, that the angle that's inside is going to face N, and then the back side is M. Okay, but also you have vertical angles, so they are going to equal the same thing. So some mixed practice. You're going to use your circle theorems reference sheet to complete this page, okay? So it's just extra practice for you, and if we need more practice in our Zoom meeting. Let's talk about chords and segments on circles, okay? So these are things that you should know. Like, for example, here, number 1, from my center to an outer point of my circle, that's my radius. And I'm searching for that length, which is 5. Okay. This one is reference to what I wrote here in your instructions. Oops. Not the entire thing, but this note. A chord that is perpendicularly intersected by a line coming from the center of the circle bisects that chord. Okay, so from here to here, this is a chord. And from my center to that chord, it's bisecting that because we've got the perpendicular there. Which means that this 11 is equal to this x, so x equals 11. All right, not too bad. Number 3 and 4, you're going to use some Pythagorean theorems. So remember Pythagorean theorem. We've got a squared plus b squared equals c squared, okay? Remember, A and B are your legs, C is always your hypotenuse. So let's take a look here. I'm searching for this length here of x, and I know this is 15.7, and I know that this is 18.9. So 18.9 is my hypotenuse, 15.7 is a leg. So I'm going to write it out as x squared plus 15.7 squared equals 18.9 squared, okay? Now go ahead, use your calculator for this because I definitely am. X squared plus 15.7 squared is 246.49 equals 18.9 squared, which is 357.21. Okay, because these decimals weren't too long, I didn't round them, and that's going to help you get a more exact answer at the end. So now I'm just going to subtract out my 246.49, and x squared is going to equal 110.72. Okay. Now we're at this point where I need to solve for just x, but I've got an exponent on it, which means the opposite is a square root. Okay, so I need to take the square root of 110.72 and find out that x then equals 10.5. And here I'm rounding to my nearest tenth now. Okay. So similar method you're going to use for number 4. Number 4 looks like, or actually you won't be using Pythagorean theorem for number 4, but x is asking for this entire length there. Okay. That's your diameter. Similar problems, you're going to use Pythagorean theorem, or you can use maybe what you've done in number 4, solving for x using your circle theorems reference sheet. So now we're not looking at solving for angles, but we're solving for lengths. I'm just going to do one of these. In this case, you've got 2 of them, or let's talk about this. So I know that you're going to use 2 chord theorem for here. You're going to use your tangent secant for this one, and also for this one. And this one is your 2 secants. So since we've got two tangent secant ones, we'll do one of them together. So tangent secant theorem, it's saying that this value squared is going to equal to 16, that's my b, times 16 plus x that I don't know. Okay. So since my 20 squared is a value that I can do, we're going to go ahead and do that first. 20 squared is 400 equals 16. 16 plus x. Okay. We can't combine inside here. We could either distribute my 16, or we could just divide everything by 16. Cancel that one. 400 divided by 16 is going to give me 25. Okay. 16 plus x. Now I'm just going to subtract out my 16. And x equals 9. All right. So just make sure you're reading your different theorems carefully and plugging it into the equations that you see there. Okay. These are similar, but you're going to use some algebra because now we're not just solving for x, you're going to find the measure of what is indicated by solving for x and then plugging it back in. Okay. So let's talk about this one is your 2 secants. This one is your 2 chords. This one is your secant tangent or tangent secant. And this one is another 2 chord. All right. I do want to talk about these ones because it is slightly more abstract than your other problems. However, very doable. Okay. So finding the perimeter of each polygon, perimeter, remember, meaning the length around all of your sides. We'll do number 15 together. So all of these can be considered as your 2 tangents, okay? So looking at your 2 tangent theorem, I know that this equals this equals this, and this equals this. Okay, I'm using different marks because it's not necessarily going to be 14 and 14 or 12.1, 12.1 over here, right? They don't match up. So 14 and 14 go here. 12.1 and 12.1 go there. And if I take my 27.9 and subtract 14, 27.9 minus 14, I get that this value is 13.9, so this must be 13.9. And now I just add up all of those together. So 13.9 plus 13.9 plus 12.1 plus 12.1 plus 14 plus 14. And my total perimeter is going to equal to 79.9. Similar here, you're going to have to go around the whole thing to figure out what this last bit of your polygon is measuring to, and then you can find the perimeter. The last ones are talking about area and circumference, so hopefully you remember those equations. If not, you can totally Google it, and solving for areas, circumference, or figuring out the radius or circumference or diameter or area given certain circumstances. Okay? If you have any other questions, you can email me and we will go over other problems in our Zoom class on Tuesday.